Hey guys, we are in the basement and today, yes today, we're working on Johnny Mnemonic, the pinball machine. No, you are not having a stroke. That intro was a tribute to John's Arcade, my personal favorite YouTube channel about fixing and restoring old arcade hardware, and that's what I'm here to do today. Johnny here needs some open heart surgery, and a lot of you have asked to see more about him, so thought I'd show you. This is just a sidebar. We'll be back to regular machining content soon, but I thought you might like a little something different. So let's go. Let's start with a demonstration of the problem. I'll power up Johnny here and show you what he's been doing for the last couple of months. Machine powers up, runs through the testing cycle. Everything seems fine, except first warning sign. The glove, the robotic arm toy that's the feature of this machine, was silent at startup. That's a problem. And more importantly, the start button does nothing at all. And well, it's hard to play a game, even on a fully functioning machine, if the start button doesn't work. Let's get inside the coin door here, and I'll show you the common element between the glove being silent and the start button not working. That's this right here. This is the front panel harness. A quick sidebar on pinball switches and lights so you understand what we're dealing with here. Pinball machines can have dozens or even hundreds of switches and lights in them, and you couldn't possibly run a wire from each of those lights and switches back to the CPU. So the way they do it is the same way that the keyboard on your computer works. The switches and lights are all in a matrix. There's a series of crossed wires with diodes joining them, and the system can scan each pair of wires there to check the status of each switch and flash each light in sequence. And if you do this fast enough, then it's not perceptible to the player, and you need only the square root of the number of wires. Now that said, some special switches are blessed, if you will, and those include the ones on the front panel. In this case, the start button and the high voltage interlock are both on dedicated wires in the front panel. So that's the clue to where the problem is here, because the start button obviously starts the game, but the high voltage interlock is the switch that detects when the coin door is open, and it disables the high voltage components in the machine, such as the flipper solenoids and the robot arm that I demonstrated was too quiet at startup. That robot arm is supposed to go through an initialization and calibration sequence when you power on, and the fact that it didn't means that the machine thinks the high voltage interlock is open, and thus it won't power up that component. So we know that the front panel harness is likely the culprit because of those two common variables. So I'm going to check the other end of that harness. To do that, I need to get inside the back box here. The artwork comes off here. This is a modern machine, so it's called a translate. Older machines, they called this the back glass because they used to actually be glass with gold leaf and other decorative elements stuck right to them. And then the door with the back box lighting just opens up. And finally, the display and speaker panel here just lifts up and lays down out of the way. If you're marveling at how easy all this is to disassemble, that's not an accident. Pinball machines are commercial coin-op hardware. They're not appliances, so they're built to be worked on. They're built to be serviced, and that shows really everywhere. Now, it might look a little intimidating here, but I'll give you a tour of the boards here. It's really quite simple. Johnny Mnemonic uses the WPC-S board set, which is a variation of the Williams WPC-89 board set, which was used in all of their machines from roughly 1989 to 1995. So this is basically the 1989 boards, but with the addition of some security features for the ROMs. Starting in the lower right here, this is the power driver board, which holds all of the big MOSFETs and such to drive the high voltage components of the game, not including the flippers, mind you, but all the other high power stuff like the pop bumpers, kickers, and so on. In the top right here, we have the so-called DMD board, which controls the dot matrix display. These classic 90s pinball machines have an amber display between the speakers that you saw earlier, and those are actually plasma displays, so they have a high and low voltage control component. This here is the low voltage control board, and then there's some higher voltage components elsewhere as well. Left of that here, we have the DCS sound board. This is an all-digital sound system that Williams came out with towards the end of '89. Top left here is the Fliptronics flipper control board, which allows some really quite accurate flipper control, enabling some sophisticated techniques that I'll do my best to demonstrate for you here later. And in the bottom left here, we have the brains of the machine, the CPU board. And this is the board that's of interest to us because there in the lower left, you can see the other end of that start panel harness that I was talking about. Over here in the lower right, you can see this big gray and big black conduit. Those are the main harnesses coming in from the playfield area. and one of them inside that conduit is this front panel harness here that comes all the way out. Now right off the bat you can see this connector looks different, and that's because I've replaced it before. The reason I've replaced it before is because of these evil things. These are batteries which hold the high scores and other settings on the machine. You can see that they've leaked in the past and corroded this ground plate here. Well, the crazy thing is, Williams originally mounted them on standoffs above the CPU board. So when they leak, which batteries always do, they leak right over all these connectors. It's a rare moment of very poor design by Williams here. So I moved the battery box outboard as you saw there, but once connectors like this have been leaked on once, it's like cancer. It's very difficult to get rid of. So I've replaced that connector and the standoffs before, but there's still some corrosion in there, so I got to do it again. The catch with this repair is that you might notice how short these wires are. Some of them are frankly pulled a little snug, and that's because they make these harnesses just long enough for where they need to go, and you might have enough length to replace the connector once, but if you have to cut the wires shorter and do it again, as I need to do, there isn't enough length. So I'm going to have to splice these wires and lengthen them, as you'll see. I'm actually going to pull the CPU board out so I can inspect and repair the header there as well if needed. I want to make really sure I get all the corrosion this time because this will be the third time I've made a repair in this area. So I'll pull all the other connectors off, and you might be thinking, wow, shouldn't you be labeling all those to make sure they all go back in the same place? And yeah, the first couple times you work on pinball machines, you do that because you're scared, and then after a while you realize that the harnesses are all exactly the right length for where they go, and they've been sitting in those positions for so long that the wiring tells you exactly where they belong, and everything just falls right back into place. So you really don't have to label anything. To remove one of these boards, it's very easy. You just loosen the screws because the holes on the PCBs themselves are keyholed. So you just have to loosen them, and then the board slides upwards and pulls right out. Once again, these are engineered to be serviced and to be worked on. It's really a joy to work on these machines because of that, which is good because you will be working on them a lot. I have definitely spent more time fixing Johnny than I have playing him, but you know, these machines are going on 40 years old now, and they were only designed to last 10 or 15. Over to my little electronics bench now. I'm going to need to rebuild the Molex connector there, so I'm putting the Molex dies in my crimper tool here. This is the Tool Aid torque-controlled ratcheting crimper. It's absolutely an amazing tool. The Molex dies are a little hard to get. They don't exactly sell them online because I don't think Molex wants them to, but give them a call. You can get them. If you haven't seen Molex pins before, here's how they work. You can see it's quite a complex structure, but very simple in function. You strip just the right amount of the wire off and you place it in like so, and there's two crimp areas, a small one up front that clamps on the wire and a larger one in the back that clamps on the insulation as strain relief. It's very elegant, but it does require the exact right tool to get a proper crimp with that. This is a two-stage die. So you need to place the wire in there and line the pin up with the profile of the die just right. One squeeze and you're done. You can see how the front area is clamped tightly on the conductor, and the area at the back is squeezed firmly but not quite as tight on the insulation. And then once you've got the pin made, here's the connector shell itself. These are very, very simple as well. They're just simple plastic shells. They come in different lengths. You just slide the pin in from the back, and the pin has a spring-loaded catch on it that latches into the connector. And you can also push that latch in and remove the pin later if you need to. It's very secure, very elegant design. I somehow have a million sizes of these shells, but never exactly the right one, so I often end up cutting one to length. You're not really supposed to do this, but you can get away with it. You have to cut it just right so that you don't lose all of the latching features that are on the connector there. And now I'm just going to proceed to make all of the wires. What I'm doing is making pigtails here with colors that match the stripes of the colors on the wiring in the machine. I don't have exact matches for the wiring that they use, but it's close enough that someone in the future who's going to be servicing this machine and is going to see the wire colors in the schematic, in the manual, and know which wires those probably correspond to. With the new pigtail harness made, I'm going to inspect the CPU here. I fully intended to replace this header on the motherboard as well, but thorough inspection here with some magnification reveals that there's really no corrosion here anywhere. As I said, I did replace this header once before, and there doesn't seem to be any new issues with it, so I'm going to leave this alone, but I am going to scrape off what little bit of a residue there might be there. Alkaline corrosion from batteries is like cancer. Once it gets into things, it just continues until you manage to cut it all out, or in some cases you can kill it with vinegar. but I don't want to dunk this board in vinegar, so I'm going to just physically remove it instead. Time to splice my new connector now. So I'm cutting each of the factory wires a little bit away from the connector. I don't want to cut them right close to it because corrosion can creep up the wires. So I want to give myself a little room there to make sure I'm cutting out all of that cancer. I cut one wire at a time, and then I strip the end of it just enough for a good splice. Give it a little twist there, and I'm going to start by tinning this wire. Splices go much easier if both wires are tinned, so I just put a little solder on the tip of the iron, touch it to the wire, and then touch the solder to the far side of the wire. Just like with brazing, the part should melt the solder, not the iron. Then I bring in my new pigtail wire, tin that as well, and slide some heat shrink over it before I make the splice. I always forget to do this, but luckily I remembered at least once. And then I do a good Western Union splice. You need a good mechanical connection between these wires. Solder is a chemical connection. It's not a good mechanical one. So for a wiring harness that may experience some pulling forces over its life, you want to make sure you got a strong mechanical connection before you solder. And then once again, a little solder on the iron to conduct heat, and then apply that to the joint and apply the solder to the far side of the joint so that the joint melts the solder, and that will all flow together very easily with the tinning. Make sure that joint is cool before you slide the heat shrink over it, or else the heat shrink will shrink right away and get bound up. I'll leave that unshrunk for now until I have them all done, and then I can move on to the next one. By doing one wire at a time, I make sure that I keep them in the same order and get the colors correctly matched up. These wires are mostly white with a colored stripe on them, so I've matched my colors to the stripe because I don't have the exact matching wire. And then the factory harness has enough length there that's still going to be visible so that, again, anyone doing a repair here in the future is going to be able to find the wires that do match the schematic. And finally, I protect the area with some foil there so I don't melt anything, and get in there with the heat gun and shrink all of the heat shrink. And then the splicing job is done. I think a lot of people are intimidated by splicing a harness like this, but once you've done it a couple of times, there's really nothing to it, and I've never had a failure in a harness spliced like this. It's really very easy. And now I can reinstall the motherboard. Obviously, installation here is just the reverse of removal. The only tricky bit is just sneaking it in behind all of the many harnesses that connect to this board. But once it's in there, again, thanks to those keyhole PCB mounts, you just slide it down and snug up the screws. And as you can see, the cable harnesses all just basically lay right where they're supposed to go, so you really don't have to worry about labeling things or fussing with orientations. Everything only goes back together one way. There's the new harness installed. Well, nothing to it but to give it a whirl. I can put the speaker and display board back in place. Gotta make sure that none of the wires get caught in that guy. That has been known to happen to me. And then close the door. And just for giggles, I'm gonna put the translate back in. I mean, you wouldn't do this if you were not confident the repair was gonna work, but I'm feeling sassy today. Plug it back in, pray to the pinball gods, power it up. Let's see what happens. Aha, right off the bat. See the glove initialize? That's a really good sign. That means the interlock is probably working. So there's a test report there at startup. What that means is the machine's diagnostics found issues. So I'll go check that out. When I open the coin door, you can see the interlock warning flash there. That's great news. That means the interlock switch is working. So I'll go into the menus here and check the test report. And it's complaining that time and date were not set. And that's because I removed the CPU board, which disconnects the batteries, and thus the settings, including the clock, were lost. But this is good because I always get some enjoyment about setting a machine's date to 2022 that was built in 1992. I often wonder what it thinks is going on. The machine requires the time and date to be set and throws an error if it isn't, because one of the things pinball machines have is extensive data collection in them. They record how well players are doing, how much money they're spending, which parts of the game they're losing on, and so on, so that the operator can tune it for maximum profit. Real moment of truth now, though. Does the start button work? Success! Look at that. Game starts, launch button works, so the front panel harness appears to now be fully functional. So of course I now need to play, 600 games or so just to make sure everything's working normally. Now sometimes I play in normal mode, but I also like to play in the more advanced cat mode. This really increases the difficulty level, I find. Now, Sprocket has learned long ago that she can't reach the ball, so she doesn't really chase it like she used to, but she does enjoy walking around looking at it and generally making my life more difficult. She also enjoys sitting in judgment at my utter lack of skill. Now, since pinball is not a normal topic for me, many of my viewers may not be familiar with modern pinball, and in fact may only know it from a drug-addled haze in the 1970s, but rest assured that pinball is not like that anymore. This is not a wooden plank with buzzers and bells. Pinball is very much like poker in the sense that newbies to it think that it's mostly luck and a little bit of skill, but experts know it's the opposite. It's almost entirely skill and very little luck. So if you're complaining that the ball always goes straight down the middle, understand that that's your fault, and you absolutely can prevent that. If you guys are interested in learning more about this, let me know down in the comments, because I could do a pinball skills video, for example, just covering the basics like live catching and drop catching, post passing, ball control, cradling, how to manage multi-ball, things like that. So let me know if that's something you guys are interested in. I'm not going to dive into that here because this video would get very long and we're already pretty far afield of my usual content here. Well, that was a very quick and dirty overview of Johnny Mnemonic and pinball in general. I hope you enjoyed that little repair, and let me know in the comments if you want to see more pinball stuff, because like I said, I'm always working on Johnny. There's lots more Johnny stuff on my blog. If you want to see more about that robot arm, I've rebuilt that a couple times, and lots more there as well. Well, thank you very much for watching, and thanks to my patrons who make all of this content possible, and I'll see you next time.